Hello, Peter here from Computer Science. I'm just going to talk briefly about the Computer Science course level at Prior. I suppose one of the things that anybody thinking of applying to Prior, they want to know what the course is about. If you have done GCSE Computer Science or GCSE IT, it will give you a good idea of the basic topics that are in the course, but it won't give you obviously the detail of what we look at. But all of the kind of topic headings that you see that you experienced in your level 2 course will be in A level: operating systems, networks, programming, algorithms, computers in society. All those will be there as kind of the same bare headings, if you like. What I've found is it gives you a slight advantage if you've done GCSE, maybe for the first few weeks, but then after that it kind of levels out because we go beyond what's been done at GCSE. So the thing is, what are the key skills that you will need? We don't ask for GCSE as a prerequisite of starting on the A level. The key skills that you will need, probably the most important one, is logical problem solving. Now, you know, it's easy to say that, but what does it mean? It essentially means that you can go through methodically to solve a particular problem step by step, and you can write it down. Now, either you like that or you don't. I mean, it can be laborious if that's not your thing, but that's the same kind of process that you need to do programming. And obviously, a computer science course, programming is a big part of it. As well as the programming, probably the single most important aspect of the course is the related thing, algorithms, which is essentially to write code on paper, right? Without putting it into the machine. So it doesn't have to be, if you haven't done any algorithms, it doesn't have to be written down so precisely. You don't have to have your commas and your colons in the right place, but it has to have essentially the same structure as the program. And that's the same kind of stuff, logical problem solving step by step. In terms of the actual the balance of the course between exams and coursework, it's 80% exams. There are 2 exams which are taken in the second year. There are no exams in the first year, and the coursework is prepared in the second year. 20% for the coursework and 80% for the exams. The 2 exams are 40% each. So there's no actual kind of hand-ins for the qualification or exams in the first year. What we do is we kind of go through most of the theory in the first year, and then we go on to the project right at the end of the first year, and that will carry on into the second year, probably up until about the end of January or the middle of February. And then we'll return to the theory to kind of finish up what we haven't done and to reinforce any difficult aspects. Now, just a mention about exam technique, because that's important given that it's 80% of the final mark. It's quite different, I think, to GCSE, where you can get away with sort of vague answers to things. You can possibly get away with GCSE if you ask what is an operating system, what are the functions of an operating system, just to say it allows the user to use the computer, which it does, but it's far too vague to get any marks probably in an A-level exam. You have to explain more precisely what the operating system does, and it might sound a bit of a chew-on because you might think you've explained it already, but the argument is that anybody can say, you know, anybody who's used a computer can say an operating system allows me to use the computer, but it doesn't have the same precision in terms of how the operating system manipulates the hardware, how the operating system kind of allows the user to use the interface to access the various applications and so on. So there's a lot more kind of detail in it, and also there's a requirement to be able to express that detail. So you've got to be willing to kind of refine your kind of approach to the subject so that you can get answers precisely right. And if you're not being forced to give sort of finicky answers, if you like, it isn't your thing, then computing probably isn't your thing. Another good indication of whether, if you haven't done GCSE, of whether you will like computing is whether you like maths and physics. Most of our students do maths, physics and computing, if they're doing computing. Not all of them. We do get some students who might be doing computing, business and media, things like that, perhaps the more kind of the graphical side of things or the more businessy end of things. So we don't have any restrictions on what combinations you will have to do computer science, but you have to have that kind of that liking for, if you like, abstract thought and problem solving. Just a few more details. In terms of the computing language we use, we recommend that you use, in our course, Visual Basic, whereas most students at school have done Python. The reason being that Python, I know in a lot of places it's a very highly thought of language, but it doesn't have the facilities that we need or to do the project. So it's Visual Studio and Visual Basic that's our main language. We also look at some others, C++, JavaScript, HTML, and a little bit of assembler language, which is a low-level language. You might have done it. We use the same thing they use at GCSE, I think, which is a Littleman assembler. It's an assembly language simulation. It's not actually a real language, but it gives you the basic ideas. So there's a range of languages, but Python is not one that we use. If you really want to kind of practice Python in the lesson, or to do your projects in Python, that's okay, you can do it, but you're limited in the amount of help that I can give you, because I don't know Python that well. I don't know every single language. You'd be better off if you wanted to do an alternative C. One of the C languages, C++ or C#, because I know those better. But if you, particularly at the beginning of learning to program, if you want to use Python, then that's okay. In terms of careers afterwards, well, there's a wide range of things that you can go into. If you want to go into a computing career. Programming I suppose is the obvious one. Games program is possible, but it's difficult to get into. It's very competitive. There's other types of programs such as data processing, getting data and displaying it. Cybersecurity is very popular. That's a very technical area, and certainly you have to be a good programmer and good at maths to do that. There's kind of more, not easy, but more kind of mundane programming, where you might be programming some kind of interface, or you might be programming how to access the data on a back-end database and how to code it to manipulate that data. There's a graphical side of it, not necessarily games programming. There's animations, web development, of course, networks, maybe looking more at the hardware side of it, network administrator. So you don't need to worry about are there jobs out there if you do computer science, because obviously there certainly are. And there are many other things you can do with computer science besides just computing. It's going to be useful if you go into a science degree. It's going to be useful if you go into just about anything, accountancy, economics, side of things, even like film studies and whatever, because everywhere, every vocation uses computers. Business, it's going to be very useful for. So as I said, just to summarise quickly, the most important thing is if you've done GCSE and you like GCSE, you're probably going to like A-level computing. If you didn't do GCSE but you like maths, and you like physics or the sciences that you do, then you will like computing. In terms of the grades we achieve, well, it is hard to get an A star, but our grades over, well, several years, the last 3 years or so, have been very good. I won't broadcast how they compare with the rest of the college, but let's just say we are nearer the top end than we are the bottom end in terms of achievement. That's adding on what students can get compared to what they were expected to get from the GCSE. Both A's and A stars are hard to get, and it does need a lot of work. Even if you're aiming for any grades, it needs a lot of work, but it especially needs a lot of work if you're going for one of the top grades. The project, for example, is going to be, for a top grade, 200 pages. There will be screenshots and diagrams, but as I say, it's a lot of work and you have to keep at it. Because if you fall behind, you're not going to get a good grade, because it's very difficult to catch up, particularly when you may be doing other difficult subjects such as maths and physics, and every subject is difficult, but those two in particular. If you do have any queries, you can either telephone the college. I won't give out my email here, but just ask for how can you contact Peter from the computing teacher or the computer science department. Okay, thank you, and hope to see you maybe at a taster day or an open day, and certainly next September. Okay, thanks, bye.